students, and I'm going to go ahead and turn it over to her now. So Sharon?
Welcome, everybody. And thank you for taking an hour out of your busy days to join this webinar and learn more about the Number World program and more about building number sense for struggling students. My goals for this webinar are to acquaint you with unique features of the Number Worlds curriculum, goals for this curriculum, and the instructional design principles that every writer who worked on the program used to create each lesson and the program as a whole, important teaching strategies to build number sense, and the effectiveness of Number Worlds for at-risk students. In addition to those goals, I'm hoping that you will take away from this webinar a better understanding of what number sense is. It's a tough thing to define. The Number Worlds philosophy, effective teaching strategies to build number sense, and math learning difficulties that many students experience. So to start my talk, I want to give you a concrete example of a real Number Worlds lesson. So I'm going to paint a scenario of a lesson, a little bit of a lesson that I observed a few years ago. So I'd like you to listen really carefully to this first part of my talk, if not the whole talk, because I will be referring to this scenario throughout my talk. So imagine a step-by-step large number line on the floor of a pre-kindergarten Number Worlds classroom. A young boy, 4-year-old boy, Samuel, standing on the number 6 square. The rest of the class is sitting in a semicircle on one side of this number line, so they all see the numbers in the same order. And the teacher then puts a teddy bear, a stuffed bear, on the number 10 square and says, "This bear wants Samuel. How many steps does Samuel need to take to get to the bear?" The students that are sitting on the floor take a few minutes to think about this question. They raise their arms so they can count in the air the number of squares they think should be counted, some of them counting underneath their breath. And one student calls out 5. Another student calls out 3. And then more quietly, a third student says 4. The teacher then says, "I heard 5 and I heard 3. Let's try 5. Samuel, take 5 steps." Samuel does this, counting as he goes, 1, 2, 3, 4, 5, and he ends up a full square beyond the teddy bear. Teacher says, "What happened?" And the students respond, pretty much all of them, "He went too long." Then the teacher says, "Let's try 3. Samuel, go back to 6 and take 3 steps." He does this, counting again, and ends up on the 9 square. And the teacher asks again, "What happened?" And the students say, "He went too short." So the teacher then revoices the student conclusions. When he took 5 steps, he went too far. When he took 3 steps, he went too short. Here she's using the student language to describe this. And then for the past 30 seconds at least in this little vignette, the students are more and more of them are saying 4, 4, 4. So the teacher now says, "Now many of you are saying 4. Samuel, go back to 6 and take 4 steps." Samuel does this. And then the teacher asks, "Did he reach the bear?" And it's very obvious that his feet are right next to the teddy bear, and all the students say yes. So why do I like this lesson? There's many examples in this 2 minutes of this lesson of excellent teaching, to my mind at least. First, it provides a physical representation of number, which is distance on the number line, that students can use to solve the problem posed. How many steps does he need to take to get from 6 to 10? It asks, the teacher asks in the lesson, and the teacher asks students to make predictions about the problem using oral language to do so. 3, it allows students to test the predictions, especially the incorrect ones, in a real-world context, to see what happens and to orally describe the results. 4, I love it that this teacher did not select the correct answer 4 to test. Many, many teachers do this. They ask a question, wait until someone in the class gives the correct answer, and then says, yes, right, that's it, and then moves on. That reinforces the one child who might have gotten the correct answer, but it curtails learning for all the students that did not get this correct answer. I expect that many of you have noticed that the incorrect answers the students gave and the teacher tested, 5 and 3, were both logical answers, and they resulted from very common incorrect add-on counting strategies. The first incorrect strategy was to count the square that you're on as the first add-on. So in this case, the students would go 6, 7, 8, 9, 10. That's 5 counts. 6, 7, 8, 9, 10. That's 5 counts. But when you're actually moving, you're starting your move on 6, so you get one step beyond. And the second incorrect counting strategy is to correctly not count the square that you're on or the number that you're on when you're adding on, but to get 3 as an answer, you also don't count the square that you ended up on. You can get 3 by just counting the numbers in between 6 and 10, which is 3. And many, many, many students, as they're learning to add on, do both of those. And most students move beyond that, but many struggling students are still using these strategies in 3rd and 4th grade, and one short or one long on every edition. So by allowing these tests of the students' predictions, all students got an opportunity to see why the incorrect strategies don't work, and also that 6 plus 4 equals 10. The teacher reinforced that formal statement right after that little vignette that I described to you. So each of these features is part of every Number Worlds lesson, from the pre-kindergarten program up through the grade 8 program. Now I want to move off to something else for just a minute. And I would like each one of you to take 20 seconds to think of your own definition of mathematics. This is the discipline you're teaching, after all, so you must have some idea of what this discipline of mathematics is all about. Use the following prompt to help you. The discipline of mathematics is about... I'm going to be silent for 20 seconds now while you think of an answer, and then I'll be back. Okay, maybe not enough time for some of you, but how many of you gave this very common but incorrect answer? Mathematics is about numbers and their manipulation via rules and algorithms. This is the most common definition by far that adults all across the United States give when asked this question. The correct answer, which is given by most mathematicians, if not all, is mathematics is about quantities. Numbers are merely used as symbols to describe quantities and changes in quantity. This picture here is labeled Core Image of Mathematics. It captures my definition of mathematics, and which also happens to be my definition for number sense. Mathematics is a set of relationships among three worlds. There's the world of real quantities, and the world of counting numbers, and the world of formal symbols. In the early years of development, from a few months old up through first grade, the major developmental task for children is to connect those first two worlds and to learn that these counting numbers gain their meaning and their sense from being connected to some real world quantities. Without that connection, those numbers mean nothing to students. And once those first two worlds are solidly interconnected, then students can make sense of the world of formal symbols, which themselves gain their meaning by their connection to the interconnected world of real quantities and world of counting numbers. To help students learn math and build number sense, we need to teach them the relationships shown in this figure I just showed you previously. And this can only be done by exposing them to elements of each world in each lesson. Think back to the sample lesson. Each of these elements was present. There was a real concrete number line on the floor that showed the distances between the numbers. That's the concrete representation of quantity. Students were encouraged to talk about the problem the teacher posed, to talk about the numbers between 6 and 10. There were actually written symbols on the number line. At the pre-K level, we didn't get students to do any formal writing or use the symbol, but in the first grade program on up, this is encouraged in every lesson. So I want now to give you 5 teaching strategies that I believe are essential to build number sense. First one is, for each math concept that you want to teach, begin instruction in the world of real quantities. Stay in this world long enough to allow students to construct a good intuitive understanding of the quantities and/or the quantity transformations that underlie the concept. The sample lesson illustrates this. First strategy. Second strategy is provide ample opportunity for students to use oral language to process the information obtained in the world of real quantities and to make sense of it. Stay in the world of counting numbers long enough to ensure that students can fluently describe the quantity transactions they have been enacting. I hope the sample lesson illustrated that strategy as well. The third strategy, this would be for grades 1 and higher, is gradually and systematically introduce students to the tools they need to record their understandings in the world of formal symbols. Make this task meaningful, if you can, by providing context in which it makes sense to create a formal record, rather than a bunch of worksheets which students do automatically, but it's not often meaningful to them that they should be doing these worksheet-type problems. 4, in selecting concepts to teach, start at students' current level of understanding. As a developmental psychologist, this is so crucial to me. And teach the concepts in the order in which they're naturally acquired, rather than the order suggested by a top-down analysis of mathematical concepts. Many curriculums are developed with mathematicians on board, and they do a logical analysis of what they want students to ultimately understand, and then they sort of backtrack and say, well, just divvy up all these understandings till we have something at each grade level. The Number Worlds program is based on developmental theory, and it follows this developmental sequence of what students can do at one age and what is the next step up in development. So the Number Worlds program is not only structured according to the developmental sequence, but well, because of that, it makes it easy for teachers to teach developmentally and follow this sequence. Many other programs don't do this. One of my prime examples, the thing that really bothers me every time I see this, is teachers being forced to teach time to the hours and minutes in grade 1 because it's on the test and because most curriculums require teachers to do that. And I've sat in so many classrooms where students have no idea. They can learn time to the hours, one dimension, but they can't in first grade coordinate hours and minutes. And it's painful to me to see students struggling with something that's so clearly beyond their developmental reach at that age. If you wait till they're in grade 2, it becomes very easy for them to handle that task. The fifth teaching strategy is let students use strategies that are natural for them as long as they need these strategies, while at the same time exposing them to a range of other effective problem-solving strategies. One big example of this is to let them use their fingers whenever they want to count or to add on. They'll give that up when they're ready, but there's no harm at all in letting them use fingers. We all do, even us adults, when we get to a tricky mathematical problem to help us keep track of numbers. A second example is very common when students are younger, in second grade and third grade even, when they're asked to solve missing add-end problems and compare problems. It's easier for them to use additions and count up from one quantity to the next instead of to use subtraction, which most adults do. And as soon as students are capable of using subtraction, they'll automatically switch strategies. But I believe it's harmful to prevent students from using strategies that come so naturally to them. So those are the 5 strategies that I think are highly important to build number sense and to make math meaningful and easy and fun for students. So what kind of manipulatives should we use to build number sense? The most common one in classrooms is objects, and we can use objects such as counters for sure to help students connect numbers to real-world quantities. But other kinds of manipulatives or number representations are needed as well, because number is represented in our culture in 5 very different forms. To teach number sense, we need to expose students to all these forms. This image here depicts the 5 different forms. If you start at the top line and work down, we'll look at the figures on the right. Number can be represented as a group of 5 objects, or as a set of dots, or as a position, in this case the 5th position on a line or a path, or as position on a scale measure like a thermometer or a bar graph, or as a position on a dial such as a clock or a sundial. When we compare quantities in each of these contexts, we use very different language to do so, and this is something that's a mystery to students, sometimes for a number of years. When we compare 5 to 4 in what's called object land in this picture, in the group of 5 objects, we say that this group of 5 objects is bigger than the group of 4, especially when they're stacked. It looks much bigger. We say that a set of 5 dots has more dots in a set of 4. We say that the 5th position on the number line is further along the line than 4, the 4th position. We say that 5 on the thermometer on a scale measure is higher up than 4, or that 4 is lower down than 5. And we say that 5 on a dial measure is further around than 4. So each of these ways of talking about number sound very different. We use very different words to describe them. And for many, many children, this is very confusing, especially for struggling students. They may not know that 5 is 5 is 5. in each of these contexts, and that we are referring to exactly the same quantity in terms of units or in terms of 1 more than 4. So the instructional design principles, I'm just going to show you 8 of them, I think, that were used to build each lesson and the program as a whole. We, the McGraw-Hill team, and me as the author, refer to this as the Number Worlds philosophy. First one, of course, is to teach specific math concepts and skills and pay particular attention to ones that are foundational for later learning. If students learn nothing more, they've got to learn the foundational concepts that they build on in all future grades. We want to expose students to the major ways that number is represented and talked about in modern cultures. That was this different representations I just showed you. We want to ensure that children acquire the interconnected knowledge that underlies number sense. This is the 3 worlds image I showed you a few minutes ago, the definition of mathematics. We want to lead children through a developmental sequence that conforms to the natural progression. We want to provide hands-on games and activities that encourage children to construct their own mathematical meanings, not giving them a formal definition that many of them may not understand. We have built these lessons to provide plenty of opportunity for children to communicate mathematically, both orally and in writing. We paid particular attention to the challenge of ensuring that the activities capture children's emotions and imaginations as well as their minds. If they're having fun doing these activities, they're going to enjoy them more, they're going to stick in their minds much longer, and they're going to be able to make much better sense of the mathematics that is embedded in each activity. And we designed these lessons to ensure that the activities that are provided in each lesson are appropriate for children from a wide range of social and cultural backgrounds, so that nobody feels excluded, hopefully, in any Number Worlds lesson. I'm just going to go over some of the unique features of the SRA Number Worlds program. These features are present in other programs, but I think in Number Worlds they're present to a larger extent because we focused so hard and so heavily on making sure that they were. There are whole class activities and small group games in almost every lesson. The games use a wide variety of number representations, especially number line representations. There are warm-up activities to give students a preparation for the main concept or skill we're trying to teach, and at the end of every lesson there are reflect activities to give students an opportunity to think about what they've hopefully learned and to consolidate their knowledge. There's a very heavy emphasis on math talk to build mathematical communication, communication and number sense. There's plenty of exposure to multiple ways of representing the concept and multiple ways to solve it. In other words, we're trying to build flexibility in problem solving and give students a really good toolkit to handle mathematical problem solving. So now, in the final minutes I have left to me, I want to show you some results from a longitudinal research study that I conducted for 3 years. I took 75 at-risk students and exposed them to the SRA Number Worlds program for 3 years in a row for kindergarten, grade 1, and grade 2. This teaching was done in a whole class context. I took 3 whole classrooms of children and worked with the teachers to have them use the Number Worlds program for 3 years consecutively. All of these students were low income. They were in the poorest school in a large inner city, and at least 95% of the students were on free lunch. I got another 3 classrooms in two different schools and found students that were matched very carefully to the students that received Number Worlds and followed this group with assessments for the same 3 years. This is called the control group, as opposed to the first group was called the Number Worlds group. The control students received a variety of other mathematics programs, whatever their classroom teacher was using. And then I found in a different school 75 average students. These were middle income students, some high income, but basically your average American middle income student, and this was called the normative group. And this group also received a variety of other programs, whatever their teachers were using. The normative group were drawn from a magnet school that was highly acclaimed in the city, and they had considered to have very good programming in all subjects, including mathematics. So all of the children were tested at the beginning of kindergarten, at the end of kindergarten, and at the end of grades 1 and grades 2. Now this first graph takes a few minutes to make sense of it, shows changes in students' conceptual understanding of number. It shows mean developmental level scores on the number knowledge test at 4 time periods. The beginning of kindergarten on this horizontal axis, the end of kindergarten, and at the end of grades 1 and 2. The vertical axis shows their developmental level score on the number knowledge test. This test is included in the Number Worlds assessment booklet, and all users of Number Worlds are encouraged to use this test. On that vertical axis, each point in the axis represents 1 year's growth. The 0 number coincides with the expected score for the average 4-year-old in developed societies. The 0.5 score coincides to the score achieved by the average 5-year-old. And the 1 point corresponds to the average score of the 6-year-old in a middle income community, and the number 2 to the average score of 8-year-olds. Let's look first at the blue line. This is the normative population, and as expected, their performance follows that of the majority of middle income students in the United States and Canada and several other countries where we've used this test. At the beginning of kindergarten, the students, they're 5 years, 4 months old. They're not quite at the 1 mark, which is the 6-year-old mark, but they're almost there. And by the end of kindergarten, all of the students have just turned 6. Their score is just a little bit higher than the 6-year-old mark. At the end of first grade, they're exactly where they should be at the 7-year-old point. And at the end of grade 2, they're almost where they should be, which is at the 2 developmental level on this test. Now if you look at the green line, which is the at-risk control sample, you'll see that these students are a good year, if not more, at some points below where they should be compared to their middle income peers. They're at the beginning of kindergarten, and they don't really change in their pattern. They're still a year below at the end of kindergarten. At the end of first grade, they're more than a year below. And at the end of second grade, even a little bit more. I've done this Number Worlds test way on up through high school, and this gap between your average student and the at-risk students actually increases as schooling progresses. Many, many research studies show that same set of findings. Finally, on this graph, if we look at the Number World sample shown here in red, you can see I picked purposely the students that scored the lowest on this number knowledge test. I put in the Number Worlds group because I thought these are the neediest children. Let's give them every advantage we can to gain some number sense and number understanding. So they were definitely the lowest, almost half a year below the control sample at the beginning of kindergarten, And by the end of kindergarten, they've made dramatic progress. They're just statistically similar to the normative group, which is the middle income group. At the end of first grade, they're maintaining their strong performance, indistinguishable from the normative population. And at the end of grade 2, they've even surpassed them in conceptual understanding of number. So my conclusion from this study, and many other studies I've done with this same test with different populations, is that the Number Worlds population does a very good job teaching conceptual knowledge of number to at-risk students. And certainly in other populations where I've used the test, there's been some students where I've used the program. There have been many students in the class who are not at risk because they happen to be in the same classroom. And the Number Worlds program seems to work just as well for your average middle income student as it does for the struggling students who need it, the at-risk population. In this next slide, I want to show you the results for computational efficiency. So the question I asked, this is wonderful that we can teach conceptual knowledge of number, but will Number World students be able to do the computation tests that are so important on all the year-end testing that all of your teachers are required to do? In order to find a really powerful test to test this, I used the test that Stigler and Stevenson used in all their international comparisons that they've conducted now for close to 20 years in Japan, China, Singapore, and Taiwan. I got the exact test from them with their scores, and in this graph, the blue line is the results that Stevenson and Stigler got from the population of children that they tested in Japan, in Sendai, which is the capital, a big city in Japan. So the blue line, you can see on this test, the first 20 items are the items that are given to students at the end of first grade. The Japanese sample did really well on all the items up through the 14th item, and then they started to have difficulty. And on the 20th item, a big double-digit item, 62 minus 36, they plummeted. They were unable to solve that problem. The interesting thing about this graph is if you look at the pink line, which is the Number Worlds population, in this longitudinal study, they are doing just as well as the Japanese children. I wasn't expecting they would do quite this well because the Japanese are the top of the world in computational efficiency. But they're holding their own on every single item against the Japanese students, and even on some items they're doing better than the Japanese students. On question number 6, which is 9 minus 1 equals, these students see these written and they can write down their answers. On number 6, they're doing better. On number 12, they're doing better, which is 8 minus 3. There's 3 items that they were doing better on, but they were all subtraction items. Well, so my conclusion from this is, again, that Number Worlds does a very good job teaching computational efficiency, and especially does a good job with subtraction. That doesn't surprise me because in Number Worlds program places a very heavy emphasis in the early grades on counting down. Endless fun little games and activities to teach counting down, which I put in that program when I first developed it, believing that this would lay a good foundation for subtraction, especially mental subtraction. And this test seems to show that that early training does pay off. So the few more pieces of data, one of the things we really want to teach in order to teach number sense is to teach operational flexibility, which is a hallmark of number sense. So this particular test was also given at the end of grade 1 to this longitudinal group. These students were first asked, they were shown a piece of paper with the problem that you see underneath the heading written on it. 3 plus 5 plus 2 minus 1 equals. And they were asked, can you think of a way, can you solve this problem? And given as much time as they needed to do so. And then, after they solved it, unless they were unable to even begin, they were asked a second question, if they were able to come up with an answer correct or not to the first question. Second question was, can you think of another way to figure this out? The Number Worlds group, as these figures in this chart shows, 96% of the Number Worlds group said yes, I can. And the second row in this chart here, 92% of these students actually got the correct answer with a totally different way of solving that problem. Only 53% of the normative sample said, yes, I can think of another way to solve it, and only 35% of the control group. Most of the students, especially the normative group and the control group, approached this in a linear fashion. They started with 3, and then they added on using their fingers, sometimes 3 plus 5, and they figured out that that comes to 8, and then they took the next number in this problem, 8. They've got to add 2 more, is 10, and then take away 1. That's a logical way for most students to start, but the Number Worlds students have a lot of training in grouping numbers to make problem solving easier. So they were able to come up with a different way if they didn't start with this different way. Some of them would say, let's do the subtraction first and get that out of the way. 2 minus 1 is 1. Then I only have to deal with 3 numbers. So maybe 5 plus 1 is 6, plus 3 is 9. Or else they'd say, oh, there's a 3 and 2, I know that's 5. 5 and 5 is 10, and then take away 1 is 9. So there's several ways to group those numbers or to solve this problem that are just different. And the Number Worlds students, happily for me, had no trouble doing this. I have 2 more slides to show you. At the end of grade 2, we gave students a much longer than these items showed, a developmental test of time knowledge and a developmental test of money knowledge. I wanted to see if the understandings they gained through this program would be solid enough to allow them to transfer this knowledge to 2 related domains that they had not been exposed to. The 2 related domains use numbers, but they're different from math. One of them is time and one of them is money. So in order to test this, there were no lessons in the Number Worlds program that these students were exposed to that taught any time concepts or any money concepts. They're just using their number sense, the Number Worlds group, to solve this. The control group and the normative group, by contrast, were in regular classrooms using regular math curricula, and every math curriculum, first grade, teaches time and teaches some money concepts, and certainly by second grade. So on the first question that I'm showing you here, students were asked, which is longer? They were asked this orally, 1 hour and 50 minutes or 2 hours and 1 minute. 93% of the Number Worlds group were able to answer that problem correctly. Most of the normative group did pretty well on this, but less than half of the control group, the matched at-risk population, were able to solve that problem. The next problem, time problem, we showed them an analog clock that was set with the hour hand to 3, and the question, and then asked, is 3 o'clock now? What time will it be in 2 hours? 85% of the Number Worlds students were able to answer that, 68% of the normative group, but only 3% of the control group, which basically are the at-risk peers to the Number Worlds group. And my final slide on the money test, for the first question shown here, we showed students a real dime and 6 pennies on the table in front of them and asked, how much do I have altogether? 96% of the Number Worlds students were able to say 16 cents. 67%, like only 2/3 of the normative group, and only half of the control group were able to get that correct answer. As most of you will probably realize, many students, struggling students, will be very tempted to discount the coins and say, I have 7 altogether, or 7 cents. The final question I want to show you, students were asked orally, which is closer to 19 cents, a quarter or a dime? And once again, the Number World students did wonderfully on this test, as well as most of the other items on this test. And as opposed to 2/3 of the normative middle income group, and as opposed to 43% of the control group. So my conclusion from this set of findings was that Number Worlds does a pretty decent job of teaching number sense, giving students knowledge that they can transfer and apply in a wide range of contexts. So I'm going to now turn control over to the organizers of this webinar and let them take over.
Okay, great. Thank you, Sharon. We do have a couple questions in the queue already. If you have a question, feel free to type it into the question chat box on your webinar tools there. And I have a few that have come in, so I'll go ahead and read those now. The first question is from Rachel. She asks, how has the new, or excuse me, Karen had the first question. What is the research for intensity and duration for a Tier 3 implementation? And Sharon, I didn't know if you wanted to answer that first based on some of your research, but I can also answer in regards to that question as well.
So Tier 3 is the lowest tier, the most struggling students?
Yes.
Yes. The time frame for that, I'm a developmental psychologist, and I do not believe in pushing students beyond where they are capable. For some students, it will take as much time as they need. My strong belief in any teaching is to start students where they are and move them up to the next lesson, the next level, as soon as they are ready. So it's hard to give you a specific answer. The worst thing you can do is rush through lessons, and students are comprehending less and less and less. Of course, for Tier 3, it's going to take longer to go through the program than it will for Tier 2 or for Tier 1.
Right. And I would just add to that for Karen, for the intensity and the duration, I mean, we do have an availability for a 60-minute block of content and instruction with Number Worlds. But then if that was too much, like what Dr. Griffin is saying, you know, we do have a scale and a model for 45 minutes of instruction as well. So it just depends if you're working with special ed students or if you guys have defined Tier 3 as just an intense group of students who were not successful in Tier 2. And we also have a research site that we will share out post-presentation with all participants, and it will give you some studies of where this has been used effectively in an RTI model. So I hope that answers your question.
Can I just jump in and add one more comment for Karen?
Sure, of course.
I missed the intensity part of her question. I'm a firm believer in 60-minute lessons. I know it's very, very hard for teachers, intervention teachers, to get that much time by the time, especially if you're pulling these students out of class. But Number Worlds is filled with games. And as my talk illustrates, I really believe you need to start by focusing on the concrete, hands-on activities. Students love these games. An hour is never too much. And then the student workbooks are more the worksheet type problems. Students might, the Tier 3 students will have a much easier time handling those if they've been given plenty of time to do the games, to talk about their experiences working with the numbers in these games. So I'm always hopeful that you can get as much time as possible, and I have never seen a student get bored and want to leave in my experience. So 60 minutes is definitely not an overreach by any means.
Great.
Thank you.
Okay, I have a few more questions in the queue. Sandra would like to know how this webinar has helped her to build number sense in the students. She's a little worried that all the talk about number worlds, she doesn't see what you're really saying when you say build number sense in students. I believe you covered it in the beginning of the presentation, but maybe you could just reiterate some of that, Sharon.
Well, I mentioned in this presentation 5 strategies to build number worlds. Number sense, sorry, that are built into every Number Worlds lesson, but those of you that aren't using Number Worlds hopefully will use these strategies. The first strategy was always begin whatever concept you're teaching with instruction, with a concrete representation of that concept. We tend to do this in the early grades with whole numbers. We have objects galore in classrooms to let students see that a 7 or a 9 or 19 is illustrated with Cuisenaire rods or Unifix cubes or any sorts of objects. What we tend to do much less is show them concrete representations of fractions. And I think this is one of the main reasons why fractions is a stumbling block for most students in North America. It's the one area where they start falling down, failing in math, hating math. So I believe in doing that. The second strategy was encourage lots of oral communication while they're dealing with quantities, so they can talk about the quantities. If they're on it, let's say 6 on a number line, and they're moving to 8, say, what is happening? How many steps did you take to get to 8? Let them talk through the problem, always using language to describe the quantities. And the third strategy that I think builds it for all students is to let them write number stories. Once they've talked about the quantities, let them use the formal symbol system to describe it in writing. And then the teacher can give them help with this or illustrate it in other ways with formal symbols, but always in every lesson connecting the formal symbols to oral words to describe it and to the real quantities. So those are the first 3 strategies. There's 2 more strategies. I'm hoping that a lot of you will take the time to read a transcript of this presentation, which I'm sure McGraw-Hill will send you. It's very hard when I'm going through this so quickly to remember everything and even to pay attention to all of these points. But if you're interested, you can go over my presentation at your leisure, and I hope, Sandra, you'll find some answers to how to build number sense for your students.
Great, and you're right, we will send out the presentation and some transcript with that as well, so the participants here can find that valuable information and share it with their colleagues. So we have a few more questions. The first one is, excuse me, I had to scroll up here. How have the new Common Core aligned Number Worlds materials changed from the previous copyright? And I can go ahead and answer that one, and Sharon, if you want to chime in.
Sure.
Basically, the Common Core, as you know and you're familiar with, has said that we have to go deeper in the content instead of worrying about the breadth. So in a lot of the modules of Number Worlds, we actually go deeper into the content, and we extended that by 2 weeks. So for example, in the geometry and measurement units, we actually spend 6 weeks on that content and focus on key standards that relate to the Common Core. And students will work on that one standard and the foundational skills that go behind that standard for a good week in order to catch up to their peers. So that's the quick highlight of how we've changed it for the Common Core. We've also decided, the authors helped us understand what the key Common Core standards were for struggling students. And of course, we have remained focused on the conceptual development and the computational fluency base of the program that Sharon has helped build to carry that through all the grade levels.
I'll just jump in now, Lindsay. That was a lovely answer. I think I couldn't do better myself. To my mind, because I've been working with McGraw-Hill on this new program for over a year, it feels like it's changed dramatically. we were teaching many of the concepts in the Common Core before, but we've highlighted the ones in the Common Core much more directly. And for me, the big challenge was the Common Core requires you to teach some concepts earlier than I believe children are developmentally ready for. Again, fractions is the big bugaboo for me, because when you look at children's mental development, it's not often until they're in 4th grade or 5th grade that they're mentally capable of dealing with this sophisticated concept. And that's when fractions used to be taught in most curriculums, but the Common Core now wants fractions introduced in grade 3. So for many, many concepts, I would look at what is required and say, oh my God, this is difficult for your average student. What are these struggling students going to make of this when they're asked to do this so early? So we all worked tremendously hard to build foundational skills that students would need to make sense of these Common Core standards. We followed religiously what the Common Core asked, but we bent over backwards to make sure that students would be able to make sense of these and handle them. And I hope we've done a good job, because I think this will make all the difference for intervention students.
Thanks, Sharon. I'm going to move on to the next few questions.
Okay.
Does the Revised Number Worlds program still include the learning trajectories in the back of the books? They are an excellent resource. It's asked by Kim. And yes, Kim, we do still include the learning trajectories as part of the program, and those are actually researched by Doug Clements. So Sharon here, our presenter, has also worked closely with Doug Clements on the revision of the product. Next. Okay, this one is a little lengthy.
Go ahead. That's a good answer.
Okay, so this one is by Matt. What is the role of a teacher's mathematical knowledge for teaching and utilizing Number Worlds? What kind of professional development or coaching would you recommend?
That's a very good question, Matt. Everyone in the United States is saying, because the United States has not done well in the past 20 years in the international comparisons in math. So, as you might know, certainly people in education realize that the teachers are well trained, and you teachers are working your hardest and doing your best to teach these students. But we haven't traditionally done a great job teaching math, and so teacher expertise is really, really important. I believe, and this is in my mind, I was not trained, I'll share this with you, as a mathematician. I'm a cognitive developmental psychologist, and I had spent years developing games to teach cognitive skills before I did my PhD work. So I got asked to develop this program to see if we could really teach cognitive skills to students, and I developed the math program and worked with a lot of mathematicians and educated myself. So my belief is teachers can learn a whole lot of math in this program along with the students. But the more math you know at the beginning, before you even use any curriculum, in the better shape you will be. It's especially important in asking good questions to students to further their knowledge, to prompt them to think more deeply. Unless you really have a solid understanding of the concept, you're not going to really know what sort of questions to ask. And even trickier, whatever question you ask and the students answer, it's always good to have a follow-up question to prompt them to think further. And to ask off the top of your head in the middle of a lesson a series of questions requires pretty sophisticated understanding of mathematics. So improving your own understanding of elementary mathematics is important, very important. One of the things that I have done a lot with the teachers I have worked with that's been remarkably effective for them two different techniques. I've had someone go in and videotape the students, and that's pretty easy to do now. In fact, I had teachers videotaping each other. One teacher might get a student teacher to take her class. She would go in and videotape a lesson for a colleague, and then have those two teachers as well as teachers. I did a lot of in-service work with teachers in groups, teachers wanting to better their way of teaching fractions or multiplication or double-digit addition, subtraction. We have a core group of 6 to 12 teachers, and we'd work together for a whole semester. And often we'd use videotapes, and then we would troubleshoot the videotapes together to say, what could you have done in this situation that would have been more effective? What was good in what you did? What could you have done a little better? And I was so impressed every single time we did this by the richness of the group's suggestions. I'm supposed to be an expert. I think I am in some ways, and I always had my own set of suggestions, but the fellow teachers of the teacher who was videotaped came up with suggestions that had not occurred to me. So that's an incredibly rich resource that I would encourage you to use. The other resource I used with teachers was asking them to keep a journal of their struggles with math. I wanted to get feedback on Number World, so I would say any lesson that you have any trouble with, make sure you note that, pass it along to me, because I want to make sure that we can improve to the best of our ability every single lesson in the program. But jot down, just keep a journal for 10 minutes of what worked in this lesson, what didn't work, and which students need more help with certain concepts. And if you get in the habit of doing that, it becomes natural, and it's not a quandary or a problem to take 10 to 15 minutes at the end of every lesson to write down notes. At first it might seem just impossible because your lives are so busy and you've got children of your own at home to rush home to, but that's a strategy that has improved the teaching of so many teachers that I've worked with.
Great. Okay. Well, we're approaching the top of the hour. I'm going to answer one more question. For those of you that have typed in other questions, we will follow up with the presenter and respond to you personally. So the last question, does the new Common Core version have an alignment document to Everyday Math, like the old version, by Joanne? Yes, Joanne, we're working on that right now for the 3rd edition of Everyday Math, and we'll be sharing that out with you. We will keep your email logged, and I'll be sure to communicate that with you directly. So for Francesca, Rachel, and Karen, there are 3 questions you asked. We will follow up with you on those questions. And for the rest of you, I want to say thanks for attending the webinar today. Like I mentioned, we'll be sending a follow-up email with a link to the recording and additional resources for you and answers to the questions. As you exit the webinar today, a survey will open, and we'd appreciate your feedback to help us improve and plan future webinars. I appreciate your engagement today as well. If we didn't get to your question, like I said, we'll follow up, and you can please email webinars@mheducation.com should you have any other questions. And one more thing, for those of you who are interested in the new edition of Number Worlds, we do have a sampler site with more information. It's listed here at the bottom of this slide, mheonline.com/numberworlds. And on there you can find versions of new materials, placement tests as the presenter mentioned, and also research. So thanks for joining us, and have a great afternoon and evening.